Hello everyone, welcome to this next video on complex analysis. In this video we shall see question from grade 2001. The question says, what is the fixed point of this function? So for finding out the fixed points, you should first know what are the fixed points of any function. So for the purpose of understanding, we say if you superimpose W plane with the Z plane, then those points which remain fixed are called fixed points. So let us understand this visually. Suppose I have this coordinate axis over here. Say this is my x-axis, this is my y-axis, and I have some point, say one point is over here and one point is over here. So now I have applied this transformation, say f of z onto this. So this is our z plane and this is our, here we have our w plane, right? So we have this function w is equal to f of z, and where this is u and this is v, right? If you write your function fz to be u plus iota v, then you have something like this. Suppose this point after transformation move here and the other point move here. And suppose we have this third point over here which is lying over here. So after transformation, this point goes to the same position and these 2 points, they shift to different positions. Say this is our first point, it moves to this position, and say this is our second point, this moves to this position, and say this is our third point, this moves to this position. So what we are intended to do here, say this is our the axis of w plane, right? So now and this is the axis for z plane. Now what I'm trying to do here is, if I superimpose these 2 planes, so that means I'm putting this z plane, this was my w plane, so now I am putting this z plane over the top of this w plane, such that there is no difference between these two. So for here I could write this to be x-axis as well as u-axis, right? And this to be the y-axis as well as to be the v-axis. So now if I mark the points, all the points from x, so the first point would be somewhere here, the second point of z would be somewhere here, and the third point of z would be somewhere here, right? So now I am marking the points corresponding to this w plane. So the point corresponding to this blue one would be here, somewhere here, right? And this green one would be here only, and this red one would be here only, right? So now you see this blue point has shifted to certain distance, this red point has shifted to certain distance, but this green point remains where it was. So that means this point is said to be the fixed point. So in order to calculate what is a fixed point, what we have to do is, we just have to substitute the function is equal to the variable itself. That means the condition for evaluating this fixed point is that fz is equal to z. So here our fz is 2 iota z plus 5 divided by z minus 2 iota. This is equivalent to writing z. So now we can evaluate this very easily. So it would be 2 iota z plus 5, that we can shift this thing to the right hand side. So it would be z square minus 2 iota z. So we have the quadratic equation in z something like this: z square minus 4 iota z minus 5 is equal to 0. So now we can solve this equation. very easily. So applying the quadratic formula, so z would be minus b plus minus square root of b square minus 4ac by 2a. This is the formula. So using this formula, our b is minus 4 pi iota, so it would be minus 4 iota z. So it would be 4 iota plus minus square root of b square. B square is basically minus 4 iota square, and then minus 4 into a is 1 and c is minus 5 divided by 2 into 1. So when you solve this, so you would have the terms of this order 2 iota plus minus 1. So the fixed points which are obtained using this expression, they are 2 iota plus minus iota. So accordingly, option C goes to be the correct option. Well, that is it for this video. I hope you understood this concept of fixed points. Well, thank you for